Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we are going to learn how to solve problem sum based on job sequence under the subject operation research. In this video, we are going to learn how to solve sum when there are one n jobs and two machines which are given. So let us see how to solve the sum. We will go through first with few important rules and thereafter we will be taking up a sum. Okay. Again, a very important topic from the exam point of view. So see that everyone go through the video very carefully.
Okay, today we'll be solving sum related to job sequencing problem with n number of jobs and two machines. Okay, now in order to solve the sum, okay, we'll first go through the question and see what is the question all about. Okay, so in the question we have 5 jobs, 1, 2, 3, 4 and 5. We have two machines A and B, and these are all the values, okay, about the number of hours taken by machine A and machine B in order to complete the respective job. Now in this sum we need to find two things: one, the idle time, and second, the total elapsed time, the total time taken by both the machine to complete the jobs. Now in order to solve that, we'll start by one. Okay, we'll go in this particular procedure and complete the sum. So step number 1, we first need to find the optimal job sequence. Now in order to find the optimal job sequence, okay, we need to create a table. Now check, there are 5 jobs available, so we'll create a table which will have 5 columns. Now remember, if there are two machines, the left side, okay, the left side of the table will represent A or machine A, and the right side will represent machine B. Now we will start finding the optimal job sequence by taking the least, taking the machinery or taking the job which has the least number of hours. Okay, now if that particular hour appears in machine A, we will note from the left side, and if that least hour appears in machine B, then we'll note it from the right side. Okay, so let us see how to do this in by actually solving it. Okay, now in this entire question we'll try to find out the least hour taken, or the most lowest number. So the lowest number or the lowest hour which is given is 1. This is the least amount present. Now the machine corresponding to this one is machine A. Now if it is machine A, we'll have to note from the left side. Now machine A has least 1 hour and it is representing job number 2. So we'll note down here job number 2. Now since I have already used this particular columns is of no use. Now let us find the second least. Now the second least hour is 2 hours, and that is under machine B. So now that appears on the right side. Okay, it represents job number 1, so we'll note down job number 1. Again, this is done. After 2, the next least is the third or 3 hours. Okay, it is represented by job A. It is represented by job A, so it will start from the left side. Okay, and it represents job number 4. The next least number is 4, and this is again over, so 4. Okay, it is under job B, okay, machine B, and job number 5. So since it is machine B, we'll note it down on the right side. Okay, and lastly we have number 7, and only one spot available, so we can note it directly. So our optimal job sequence is first, job number 2 will be done, then job number 4, job number 3, job number 5, and lastly job number 1. Now let us see how we need to calculate, or what is the format of calculation of idle time and the elapsed time. So now this is the table that we need to create. The first column will have jobs, Now here, since there are two machines, so we'll have machine A and second will be machine B, and we'll have the idle time. Now in machine A, we need to find the in time and out time. Similarly for B, in time and out time, and idle time we have to find for machine A and machine B. So this is the basic format for solving job sequencing problem. So first step was we need to find the optimal job sequence, and secondly we need to do the calculation. So this is, I can say, second step where we're going to do the actual calculation. Now under job, we'll have to note down the optimal job sequence that we have got. So here it will be job number 2, 4, 3, 5 and 1. Okay, now let us see how we need to solve this. Okay, now always remember कि the first machine job, the in time will always be 0. मतलब from 0 hours you are going to start your work. Now check in machine A under job 2 how many hours did it take. So for machine A under job 2 it has taken 1 hour. So my out time will be 0 plus 1, which is 1. So it has taken 1 hour. Now for one job, whatever is the out time, for the second it will become the in time. So we cross it, we bring 1 down. So now next job is job number 4. In job number 4 for machine A, it has taken 3 hours. So my out time will be 1 plus 3, which is equal to 4. We bring 4 down. Okay, so my next out time will be 4 under job number 3 is 9 hours going to take. So 9 plus 4 is 13. Again we bring 13 down. Next will be 13 plus, in job number 5 it has taken 10 hours. So here it will become 23. Okay, we bring 23 down. Okay, and lastly it will be 23 plus job number 1 has taken 5 hours. So total is 28. Okay, so we first start with 0 and then we keep adding the number of hours that have been taken by the respective number of job. That was for machine A, the first machine. Now let's see how to start the second machine. Always remember, first machine first out time will be equal to the in time for the second machine. So whatever is the out time under your first machine, that will become your in time for the second machine. And now we have to follow almost similar procedure, but we just have to be careful in one point that we'll see. Okay, machine B under job 2 has taken 6 hours. So the out time will be 1 plus 6, which is equal to 7. Okay, again the rule was whatever is the out time will become the in time, but now here you have to be very careful. If the out time is more than, if the out time of machine B is more than that of machine A, then it has no issues. You can directly bring it down. So here it became 7. Okay, but if it would have been less than the the out time of machine A, then there will be one small effect that we'll have to do. So we'll see that ahead, but here as of now it is greater, so we bring it down. So out time for the next job will be, now this is job number 4, which is 8. So 7 plus 8 is 15. Again this is 15. This is 13. 15 is more than 13, so we bring down 15 as it is. Job number 3 mein it has taken 7 hours, so it will become 15 plus 7, which is equal to 22. Now this is 22. Okay, the next out time of machine A is 23, so you cannot get 22 down. Simple logic, machine A need 23 hours to complete job number 5. Machine B cannot start with 22 hours. It will usually have to start after 23 hours or at 23 hours. So if the number, okay, if the total out time is less than that of the first machine, we bring the same number down. Okay, we carry the out time 23 hours. Okay, we'll bring it here. Now here what happened is machine B had already finished its work at 22 hours, but it cannot start because machine A will take 23 hours to finish that job. Only after that machine B can start. So here machine B had to actually wait for 1 hour. So the idle time of machine B under this case became 1 hour. Thereafter we can directly solve now further. 23 plus, now job number 5 was 4 hours, so it became 27. Now again 27 I could have bring it down directly, but here it is already given as 28 hours, so you cannot start the job B at 27 hours, so you'll have to start it at 28 hours. Again 1 hour idle time will be recorded. Lastly 28 plus job number 1, it has taken 2 hours, so total became 30. Okay, now let's take here, now see here, machine A took 28 hours to complete the job, whereas machine B took 30 hours to complete the job. It means machine A had to wait how many hours now here? It had to wait 2 hours. So that was the idle time that machine A had, because otherwise it was all in normal coincidence, like 0 1 1 4 4 13 13 23 23 28. So there's no gap between that. The only gap between us the 28 to 30, so 2 hours idle time. Now machine B started with, after 1 hour. The in time was after 1 hour, so meaning from 0 to 1 it had to wait, so another idle time get appears here. So in total A had an idle time of 2 hours, whereas B had a idle time of 3 hours. Okay, so to conclude this, number 1, we need to first find the idle time. So the idle time for machine A is equal to 2 hours. Idle time for machine B is equal to 3 hours. So the total idle time that the machine was idle is 5 hours. And finally the total elapsed time, that is the total time taken to complete all the job by both the machine, is the total is 30 hours. Okay, so this is how we have to solve job sequencing problem sum, where there are n number of jobs and 2 machines.